Hello. In this video, we're looking at dealing with missing data using pandas. So in this exercise, we're working on the dataset that we've seen before. This is the country demographics data from Gapminder. Except that in this spreadsheet, some of the numerical entries were corrupt. So for instance, if you look at the second row here, you can see that this number is followed by NN. So these entries were artificially corrupted in order for us to work in this exercise using the same familiar data that we have. But this is a very common situation, especially when the data is coming from the internet or when the data is scrapped from another source. Many often data will come missing, some entries will be corrupt, and so on. So this exercise is very similar to the warm-up exercise, except that we are dealing with corrupt numbers rather than missing numbers. It's asking us to calculate the average life expectancy, population, and GDP per capita. So if you pull any one of these columns from the data frame, and if we do mean to calculate the average, we're going to get an error at some point, simply because one of these values is corrupt. And not sure what's this error is trying to tell us here, but it's basically trying to convert all of these values to numbers, but not all of those values are numbers. So how do we know? Like here, we've seen that the second entry in GDP per capita had an N, but there are so many rows. A shortcut to see what kind of data we have is to do data, which is the data frame.dtypes, which stand for data types. This one is going to tell us what pandas think about each one of these columns. So pandas thinks that country is an object, continent is an object, which is fine, those are strings. Year is int64, which is fine, we know that year is integer numbers. However, life expectancy, population, and GDP per capita are all object. Although it makes sense that life expectancy is a float, population is an integer, and GDP per capita is a float. So we have corrupt entries in each one of these columns, and we need to deal with these corrupt entries. So the exercise is asking us to replace these corrupt values with NaN. And then if we do that, we should be able to do the mean, because pandas knows how to drop the missing values, or we can drop them ourselves. The key goal of this exercise is to be able to replace these values, and there are many of them. So of course we can replace a value manually. We can do something like data.iloc, for instance, 1 and -1, right? 1, row 1, and then -1 should be np.nan. And if we do data.head, we've dealt successfully with this corrupt value, right? Okay, that's fine, but if we try to do data GDP per capita dot mean, we're probably gonna get the same error again because there are other corrupt values. So we don't want to kind of sift through the data kind of manually. That defeats the purpose. We need to be able to do this replacement automatically. So we have dealt with this similar situation early in the course when we had a list of values and not all of these values were numbers, and we had to convert them to numbers and exclude the non-numerical values before calculating the average. That's a very similar exercise. So remember, we use two ways to detect non-numerical values. The first one is to use the function isNumeric from the string class. So if we pick, for instance, data.iloc, let's pick the first one, 0, -1. That's a string. If we do isNumeric, we're going to get, or isDigit, I think, we're going to get a true or false value depending on whether this string is a digit or not. In this situation, we get a false simply because isDigit doesn't work for float values, it only works for integer. So if we do -2 here, we're going to get true because this value is all numbers, it's all digits. So then in this case, we have to write our own function to detect whether a certain value is a number. So I'm going to write this function here, is number, and the basic idea is it will take a certain number n, and it should return either true or false depending on whether this value is a number or not. So for now it returns always true, and then what we can do with this function, we can use it in order to detect whether certain values are numbers or not. Okay. Similarly, if we want to convert to not a number value, we can create a function called convert number. And if this function well, let's leave this one here, convert number, convert to number n, and this function can test whether this is a number. If it's a number, if is number n, then we can return float or int. Let's do float n. Otherwise, we can return np.nan. Okay. And then we can use this function to convert all of these values, all of the values in each one of the columns. Okay. So we have seen this before. If we want to convert all values in life expectancy, we can use the function apply. Apply, and we can apply convert a number, and this one will convert all of these values to numbers. Of course, we got this error, right? We cannot convert 75.32 NN to a number, and that's simply because this function is incomplete. It's just a stub. But kind of that's the overall design that we want to follow. We want to focus on writing in this function. If this function knows how to determine whether n is a number or not, then we're good. We can detect whether the value is a number, and then based on that, we convert it. All right, so let's think about this value here. The function is number needs to return true if n is convertible to a number, otherwise it should return false. So there are different ways to do it. A very manual way to do it is to go for each character in n, and then if c is not in numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or dot, then it has this. Of course, this is not a number, and then we need to return false. Okay. Otherwise, at the end, we can return true. Of course, all of these have to be strings, so string values. That's one way to do it. Another way to do it is to use exceptions. Try to convert to a number. If it raises an exception, returns false, otherwise it returns true. Yet another way to do it is to use regular expressions and try to match a regular expression for a generic number. Right, so that's one way to do it. Let's try it now, and you can see that now it converts all values to numbers. Let's save this one to a series here, and let's look at the values that are null, is null, and you can see there are some values that are null, but they're not shown here, so I'm going just to filter based on that. And you can see here that there are at least like maybe 30, maybe 25 values that are nulls. For instance, at index 59, there is a null value in life expectancy. So if we do data.iloc 59, we should see that discrepancy here, right? Okay, so that's it. We're going to use this function to convert all columns. So let me start with life expectancy here. Let me do population. Let's reload the data from the start. So we have the first corrupt value in GDP per capita as well. So let's look up population, and let's do GDP per capita, which is the last column here. Alright, so if we do data.head now, you can see that these replacements are in place. So now if you look, you can see that it's kind of detecting that each one of these columns is now a numerical one, except life expectancy. So I'm not sure why it's not detecting life expectancy as a numerical column, but we're going to put this to test when we calculate the mean. Looks like we're still having an issue at some point in life expectancy. 2, 3, 4, 5, 6, 7, 8, 9, and dot. So one of these values has created an issue. And maybe our test for whether that is a number is incorrect in the function above. So let's try to see which one of these is the offending values. Of course, it could have been that this test is incorrect if you have a number that contains multiple dots. And this error message is not very helpful. It's not showing us what value, which value is creating this issue here. So what I'm going to do here, let's write, in order to look at what value we have for each value in data life expectancy, I'm just going to try to see if float value and see which one is not possible to. Okay, so it looks like I reloaded the data, but I forgot to run the code here again. So let's reload to the data one more time and run the 3 steps. This one, and this one. And this should be fine now. Okay, so let's do life expectancy. Let's do data.dtypes. Alright, they're all numbers. And now if I do data.population.mean and data GDP per capita .mean, I should get these values. Now when we use the built-in pandas functions, they know how to drop the missing values. If we're doing this manually, for instance, if we do some data GDP per capita over length GDP per capita, that's not going to work because the not a number will be added to other numbers and we will get not a number. So we need to manually drop NA if this is what we are doing, if we're doing things manually. Okay. All right, so before finishing this exercise, we have done this kind of a process manually, implementing a function that tests for whether a certain value is a number or not, and then we applied this function to all values in multiple columns, in multiple series here. Also, it turns out this is such a common operation to try to convert text to numbers. So Pandas has a built-in function for doing so. So let me show you the built-in function. I reloaded the data, so we have corrupted values. And the function is called pd.toNumeric. And this function will try to convert any argument, including series, this is also a universal function, or a single value, to a numerical value. The second parameter says what the function will do if it cannot make that conversion. By default, it's going to raise an error, but we have the capacity to coerce this invalid value to not a number. Ignore will simply returns the same corrupt value. Let's take a look. So if I do pd.toNumeric 57.3 and n, I'm gonna get an error here because this value is not convertible to a number. If I do errors is equal to coerce, I'm gonna get not a number. If I get errors equal to ignore, I'm gonna get the same value. Of course, what we are interested in is this one. And then we can pass in the whole series here, data life expectancy, or what all of the series, and we can get the results here. So instead of writing our own function, there is a built-in function. It happens to be a universal function in this case, so we don't need to apply, although we can use apply as well, but we can use this built-in function in pandas to achieve the same results much faster, because we don't need to kind of think about the details. All right, so once this is done, we can do mean, and pandas will know how to calculate those values without by dropping the missing values.